Hello, this is me, Sarvesh, BTech undergraduate student, and I am here to explain about my project. And my project goes like my project goes like a graph neural network framework for semantic document understanding. Actually, in the first phase of my hackathon, my project goal was a web platform with AI pipeline that automatically detects and deducts personally identifiable infos from payroll documents. Payroll documents can be a payslip, a bank statement, a credit card detail, or anything. And we have many personally identifiable infos like Aadhaar, PAN, or even our name could be a personally identifiable information when we are sharing it with someone else. So my aim was to give it to a paddle or OCR and extract OCR, and I use paddle OCR and extract text from those images, and a simple LLM model like Quen or Olama or Gemini using API calls or something, and we can extract personally identifiable information. Since we are highly dependent on privacy, so I thought the change is needed. So I switched this to API call to a local model. When we go to a local model, there's always a fault like there's storage problem. So when we go for privacy, this model should be small as well. So there are many people who do this, and they take a small model, they train it on like I used pay slips. They train it with 1,000 pay slips or 10,000 pay slips, and the problem there arises is um, the model cannot bring in correct output when I give a new format to it. What if I give a 10,000 format? It fails there. So what I came up with the solution is I designed a pipeline, not an exact solution. I mean not a solution. I mean exact pipeline to solve a problem. The problem is um, will I will say the problem what is. But my project goes like a graphical neural network framework for semantic document understanding. So this is how my project changed from that to this. So let me go on and explain what's in this. So basic problem is we have there are many structured documents, right? The structured documents can be a payslip, bank statements, credit cards, and those might be shared with someone else. So we need to identify a personally identifiable information from them. That was the ultimate aim. But what I changed to it now is we have a structured document. So we perform OCR on it and we extract text. So when we extract text from those OCR, let's say for example a payslip, I say in a payslip there's an employee name and the name could be something XYZ. This employee ID and it could be 123, and there is some other key and value. So when you extract OCR from that image, you lose the key value pair. So this is the main drawback of the existing models. Large models like Gemini 2.5 Pro, which is launched right now, could solve this, but it's not private. So based on this, I developed a pipeline. The pipeline goes: you give an image to the OCR. I use the easy OCR and paddle OCR, and it extracts text, and the texts are with bounding boxes. For example, I have uploaded an image as well, and yes, if any as you can see here, there's an image of a payslip which is sampled, and this is what the ECOCR extracted. You see, this is Southern Trust Finance Limited. These are all the labels and keys, and employee name and employee ID. These are what I said are keys, and these are values. So the problem here is the key, the earning is like 29, let's say 29,000 here. So when you give it to a normal LLM model, this basic loses its key, its value. It may correlate with any values. So what I did is I used GNN, graphical neural network, in that graph sage, and uh, I trained on a payslip which I synthetically generated with the different formats, and this is the visualization. This is the visualization. The green dots represents the keys, and this red dot represents the values, and the line connecting between them represents the key value relation. Through my approach, we can easily find the key value relationship from an extracted OCR. That's what I tried to achieve, and I trained it on 300 data sets, and it's having accuracy of 82%. Thank you.